Let's walk through these practice problems from practice quiz 4.1. All right, so question 1 asks, what's the orbital period in years of a planet with a semi-major axis of 10 AU? All right, so anytime we're dealing with these kind of orbit problems, we're going to use the equation p squared equals a cubed. Now, there's two kinds of problems we might encounter. One where you have to solve for p, the orbital period, which is what question 1 is asking, or where you might have to solve for the semi-major axis, A, which is what question 2 is asking. So we have to do a little algebra to solve these equations. So let's do that. So in this case, we want to be able to solve for the orbital period when A is equal to 10 AU, okay? All right, so when that's the case, we're going to do the algebra here. So to get this thing by itself, we have p squared. To get it by itself, what we have to do is take the square root of both sides. So the square root of p squared will equal the square root of a cubed. So this square root cancels the squared, and you're left with just p equals the square root of a cubed. Now, when you actually do this calculation, there's a couple different ways you could do it. One is you could plug this into your calculator, and you could first, if you're following the order of operations, you first have to do whatever's inside the square root. So this would become the square root of 10 cubed. So the first thing you would do then in your calculator is you'd figure out what is 10 cubed. So you would have 10, and your calculator might have a cubed button. This one does, 10 cubed. Or you could do raising it to the power, x to the y. Sometimes it's like a caret button, like just a caret. Let's see, it looks like this, caret. That's like raising it to the power. So I could say 10 to the power of 3, like that. So it's 1,000. Or I could say 10 times 10 times 10. That's the same as raising it to the power of 3. So 10 to the power of 3, or 10 cubed, is 1,000. So then this would become then equals the square root of 1,000. Okay, so once I have 1,000, I can take the square root of that. And I should have a square root button here, right there. Square root. And I get 31.6, which would be years. 31.6 years. Now I want to show you just a slightly different way of doing this. Same idea, but another way of writing a square root is to write to the power of 1/2. Okay, that's the same as saying a square root. So if you were to put something to the power of 1/2, then this would become like p equals a cubed to the power of 1/2. So I could put it like this whole thing in parentheses, to the power of 1/2. You might be like, why would you do that? Well, we'll see in the next problem why, but one reason is that if you're familiar with your rules of algebra, this is the same as saying a to the power of 3/2. And 3/2 is 1/2. So this is the same as saying just a to the power of 1.5. So if you wrote down that equation for yourself on your equation sheet, like a rearranged version of this to say, like, well, you could just say p equals a to the 1.5. That is also true, right? This is the same as the equation you're given on the equation sheet, which is p squared equals a cubed. And if you were to type that into your calculator, then a to the 1.5, this becomes then 10 to the power of 1.5. Okay, and if you type that in, you would write it like this. You would say 10 caret, or x to the y here, 1.5, and notice how you get the exact same answer. 31.6. So whatever way makes sense to you, I just want to show you there's more than one way to figure this out. Okay, now for the next question here, question 2, what's the semi-major axis of a planet with an orbital period of 25 years? So now we're given that P equals 25, and we have to find A. So again, we're going to do some algebra. It's going to be similar, except now we want to get A by itself. So if we're starting with P squared equals A cubed, how do you get A all by itself? Well, to get it by itself, you have to take the cube root, it's called, just like the square root, except it's the cube root. So you end up with the cube root of P squared equals the cube root of A cubed, right? And the cube root cancels out the A cubed, so you're left with just A by itself, and that's where you get the equation then that we would use, which is A equals the cube root of P squared. So just like before, we could solve this the same way now, where we put this in, we'd say, okay, it's the cube root of 25 squared. All right, so let's put that into our calculator. 25, we're first going to do the 25 squared, right? So 25 squared is 625. So now I have to do the cube root of 625. And now how do you take the cube root? Now your calculator might have a cube root button. You'll notice my calculator on my computer does right here. This is the cube root. See the little 3 there? So I could take the cube root of that and I get 8.55. We'll say 8.55. Now if your calculator doesn't have a cube root button, that's where we need to use this other kind of approach. So this, by the way, the units are AU, but you would just write 8.55. So if you don't have a cube root button, what we can use is the same idea we used before, which is that taking the cube root is the same as raising something to the power of 1/3. Okay, the square root was 1/2, well, cube root is 1/3. So I could also write this as A equals P squared raised to the power of 1/3. Okay, which is the same, just as I did before, as saying that A equals P to the 2/3 power. Okay, so if I were to do that, then and type that into my calculator, 2/3, you'll recall, is like 0.6666666. So I could just take it like this. I could say, okay, I'm starting with 25. I'm going to raise it to the power, x to the y, or caret, to 0.6666666. And what do I get? I get the same answer, 8.55. Okay, so depending on how you're most comfortable to calculate this, you might want to write the equation different ways. So again, on your equation sheet, you could just add this rearranged version of the equation, that A equals P to the 2/3. That's the exact same equation. It's just the algebra is already done for you. Okay? Let's take a look at question 3. Question 3 is asking us to calculate the force of gravity acting between the Earth and a 100-kilogram person standing on the surface. All right, so this is probably one of our most complex equations in the whole course. The force of gravity equals the gravitational constant times the mass of the big thing times the mass of the small thing divided by the distance between them squared. Now the distance between things is always given as the distance between the center of mass, so like the center of the Earth to the center of the person, you'd say, right? Or the center of the Earth to the center of the sun. So in this case, we have to figure out what we've been given. Now g is a constant. I should pull up our equation sheet, don't you think? Let me pull it up. Okay, so here's our equation sheet. So here's the equation, g m1 m2 over r squared. Now there's a bunch of constants here, right? Because g is this gravitational constant, which is given to us. Okay? And you'll also notice that the mass of the Earth is given to us right here. Mass of the Earth is 5.97 times 10 to the 24. And then we also have the radius of the Earth, 6.37 times 10 to the 6. So those are values that we're all going to use as we solve this problem. So this is a lot of scientific notation, right? Where you're multiplying times 10 to the power of something. So we have g is given to us, that's 6.67 times 10 to the negative 11. Okay, M1 will be the Earth. That has a mass of 5, I'm getting this off the equation sheet, 5.97 times 10 to the 24 kilograms. All right, the second mass is the mass of the person, which is going to be 100 kilograms. And then R, I'm out of room here, will be the radius of the Earth, which in this case is 6.37 times 10 to the 6 meters. So what we have to do is be able to plug in all of these values into our calculator because it's already written here. Now, a couple suggestions. One is that when you're dealing with scientific notation, you can always use parentheses to help you, and I'll show you that as we type it in. The other thing I want you to see, though, is that you can use this gravitational force calculator. Let me just pull that up a second. So here's the gravitational force calculator. You'll see it has the whole equation here and these values plugged in. You'll notice that G is always given there, 6.67 times 10 to the minus 11. But then you can type in your own values here for M1, M2, and R. Now, I don't want you to lose points on just typing things into your calculator. So if you want to use this gravity calculator that's linked in the assignment in the lesson, you can. I want to highlight, though, is notice how to type things in. See, M1 here, you can just jump right to like the mass of the Earth, right? That's pre-programmed, so you don't even have to type it in. Okay, and there is a mass of a person, but you're asked specifically about 100 kilograms. So to type that in, you could just type in 100, okay? And notice how it rearranges it in scientific notation, where you see how it says 1.00 E2. Well, that little e is the same as saying times 10 to the. So the same thing here, you'll see it says 5.97 times 10 to the 24. Well, when that's being typed in, you can just say 5.97 E24. And you could type it that way. So for the radius of the Earth, I could just type in 6.37 E6 and hit enter or click out of there, and it does it for me. Right, and now what I want to highlight for you, though, is that there's a lot of gobbledygook up here. Notice that it's calculating right here. It's doing the calculation, and then it shows you the answer in the second line. So this is 9.81 times 10 to the 2. So you got to be able to read the scientific notation, too. So 9.81 times 10 to the 2, that would be 9.81 times 100, 981 newtons. So you can use this, all right, but let me show you how I would do this on a calculator. Okay, so what I would type in, okay, now on your calculator, the trick is this whole scientific notation business. Okay, so scientific notation on your calculator, it'll depend a little bit on your calculator. So you'll see this one on my computer has a 10 to the button. 10 to the power of 10. Okay, so you might have a capital E, a button that just has a capital E. And I know that the Newton's gravity calculator had a lowercase e, but usually on a graphing calculator, it'll be a capital E. And that capital E again means times 10 to the power of. So here's how I would type this in, all right? I've got 6.67 times, here's how I would do it, okay? I wouldn't even use this 10 button because it gets confusing for me. I would write 10 to the power of 11. See, it's getting me in trouble. All right, let's try again. 6.67 times 10 to the power of, and now on here I have to put 11 negative. Okay, that's my first, and I'm gonna hit enter. That's the value. Now I hit enter in between. It's kind of like using parentheses. It's making sure I got all these values kind of separate, okay? And then I'm gonna say multiplied by M1, 5.97 times 10 to the power of, x to the power of 24. Enter. Okay? Now I need to multiply by M2 times 100. Enter. And now here's where it gets a little tricky because I'm going to divide by something squared. So I'm going to say divided by, now because I'm squaring what's down here, I'm going to use parentheses. So I'm going to say parentheses 6.37 times 10 to the power of 6, and then I'm going to close the parentheses and square it. Squared. And then I hit enter, because this is not the final calculation here. This is just showing an intermediate step, so I have to hit enter to be done, enter, and I end up with 981, which, if you recall, is the same as what that gravity calculator gave me, 981 newtons. Okay, so 981. Now I recognize that that is not necessarily easy if you haven't had a lot of practice with typing things into calculators. One thing, if you're using a graphing calculator, you could use lots of parentheses. You could put a parentheses around every one of these values if you wanted to, just to make sure that they are being separated by the calculator. You know what I'm saying? Okay, let's try another example. Let's look at questions 4 and 5. All right, we have 2 more gravity problems. Let's take a look. Force of gravity acting between the Earth and a 60 kilogram person who is 400 kilometers above the surface of the Earth. Okay, so what's tricky here? What am I being given? All right, I've got my equation. So force equals gmm over r squared. I know g. I know that one of my masses is going to be the mass of the Earth. I know that the other mass is going to be a 60 kilogram person, so 60 kilograms. And then I know the radius is going to be the radius of the Earth plus 400 kilometers. Now, the radius of the Earth and really everything in this equation should be in meters. So this is the radius of the Earth plus 400,000 meters, right? Because 1 kilometer is 1,000 meters. Okay, so I'm going to plug these values in and do my calculation. Now again, let's do the intermediate here, right? Because I'm going to use my equation sheet so that I know where to go. Equation sheet, here you are. Okay, so that I know what these values are, these constants. So I have what g is, the mass of the Earth. I don't remember offhand, but it is, I can look it up, 5.97 times 10 to the 24. 60, and then the radius of the Earth plus 400,000 here. So the radius of the Earth, and I'm going to use my calculator for this, right? Because this is in scientific notation. So the radius of the Earth is 6.37 times 10 to the power of 6 meters, that many, plus 400,000 meters. Okay? So you could write this in scientific notation, or you could just write it out as a number. 677, oh, I lost it, 0, 0, 0, 0. 0, 0, 0, 0. Okay, that's my radius. So now I can type this into a calculator. Again, if I were writing this all out, it would be, I hardly want to because it's so many numbers, but the force is 6.67 times 10 to the minus 11 times 5.9 times 10 to the 24 times 60 divided by parentheses 6,770,000 parentheses squared. Now the reason you might want to use parentheses, by the way, is that these exponents can kind of get muddied in. If you're not careful, you might accidentally multiply your exponent by the next number. And so sometimes putting parentheses around these can just kind of help keep everything separate. Okay, again, especially if you're using a graphing calculator. Okay, so let's do this. 6.67 times 10 to the 11 negative, enter, times 5.9 times 10 to the 24, enter, times 60, enter, divided by 6,770,000. And now, so I just divided by it once. I'm going to divide by it again, because that's the same as when you divide by something squared. It means you're dividing by it twice. So I'm going to divide again, 6,770,000. All right, and I get a number, which in this case is 515 newtons. Now here's a hot tip, all right? Hot tip. If you get an insanely large or insanely small number, you did something wrong, okay? Because I've set up these questions so that they're going to be numbers that you can actually type into the quiz without using scientific notation, all right? So the answers should be, between 0 and 10,000 usually, all right? If you're getting something way out of there, you've done something wrong. All right, let's do one more. Force of gravity acting between the sun and an 80 kilogram person who's 1 astronomical unit away. So let's write down what we know. The big mass is going to be the mass of the sun, which from my equation sheet I can see is equal to 1.99 times 10 to the 30 kilograms. Okay, the second mass is going to be 80 kilograms. And then the distance is 1 AU, which again from my equation sheet I'm given is 1.49 times 10 to the 11 meters. All right, so let's plug in our equation. The force is going to be G, 6.67 times 10 to the negative 11 times big mass, 1.99 times 10 to the 30 times the small mass, 80 kilograms, divided by the distance squared, 1.49 times 10 to the 11 squared. All right, let's take a look. 6.67 times 10 to the 11 negative, enter, boom, times 1.99 times 10 to the power of 30, enter, times 80, enter, divided by parentheses 1.49 times 10 to the 11, close parentheses, squared, enter. Don't forget that last enter. And look at that. It all came out to a number, a relatively normal number, 0.478 newtons. Okay, so I hope this is useful. And yeah, I know it's not easy, so take heart and keep practicing, and you'll definitely get the hang of it.